Bienvenidos, Hushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the spring 2021 semester. This is the CCNP ENCOR version 8 curriculum, and in this supplemental tutorial, we're going to be taking another look at Cisco's proprietary Hot Standby Router Protocol, or HSRP. And we're going to be investigating how we would track interfaces that, if those interfaces were to go down, we could decrement the priority and possibly switch the active responsibility from a router that has lost upstream connectivity over to another HSRP router. In this case, it would be the standby. And so we're going to do this in a built-in fashion. Now, there's something referred to as enhanced object tracking, which is where you can configure IPSLA to track specific interfaces. Here, I look at this as sort of the built-in, more generic interface tracking, and we'll take a look at an IPSLA example as well. But I like to refer to this as sort of HSRP's built-in tracking, where we're going to go ahead and define an object, which is going to be an interface, and then we're going to track that interface. And let me show you the use case that we're interested in here. Now, this activity has not changed from the previous video last night. You can see that PCA is able to ping the internet out here behind router 2 being simulated with a loopback address. And so right now, the use case that we worked on last night when configuring HSRP is if this interface goes down, or if that interface were to go down, or if that interface went down, or this interface went down, HSRP between these routers, which is communicating across this LACP ether channel link here between switches for router 1 and router 3, the connectivity and the communication from an HSRP perspective would be lost. And as we saw, that facilitates the failover for the HSRP group in question, if it was over here on router 1, which is the primary for VLAN 10, then that active responsibility would shift over here to router 3. And the same is true here for PCB, which is in VLAN 20. Again, remember, we're doing multi-group HSRP right now. But if this interface went down, then HSRP would recognize that, hey, router 3 from an HSRP perspective has become unreachable. Remember, HSRP is not being communicated with through this link here. This link and these links that make up this triangle between routers 1, 2, and 3, that is OSPF that is running on these links. HSRP does not communicate between these links. And again, you wouldn't want it to, because if that interface right there went down, then we're not going to be able to get from PCA to router 1 via this LAN segment. And this is layer 3 up here. Remember that. Let me draw a little line in here. This is our layer 2, layer 3 boundary is right between these devices. So the MAC address table is not going to be communicated for the LAN segments between router 1 and router 3 on this layer 3 link. Right? So the boundary becomes important as well. So the first use case that we're going to look at, because you might be looking at this and you might be saying, okay, well, we've got redundancy up here. But here's what we're going to examine. Let's assume that this link doesn't exist between router 1 and router 3. What if we have just a horseshoe type architecture? And that's actually a technical term that is used to describe what this architecture would look like. And let me draw this up here. We have a horseshoe, so to speak, right? And so in some cases, and I'm looking at the key here to get rid of that. There we go. In some cases, you might end up where you do not have a link between router 1 and router 3. And so I've already taken the liberty to shut this link down between router 1 and router 3. So we do, in effect, have a horseshoe topology here. So let's see what happens with PCA, and you can see PCA is happily pinging that internet IP. If I come on here to router 1, and I'm going to shut down the interface between router 1 and router 2. Again, there's no redundancy up here from an OSPF perspective, from a layer 3 perspective. So what's going to happen with HSRP? So let's get into global config. Let's go into int gig 00, and let's shut the interface down. So the first thing I want to take a look at is let's come back over here to PCA, hit enter a few times, and what about the ping activity? Do I have reachability out to that internet behind router 2? I don't. The pings have stopped. And it's because, again, remember, the redundancy here from a layer 3 perspective is gone, right? So here's the first use case we're going to address. If you have a horseshoe topology and you're running HSRP, like a good network engineer would, and this interface goes down, how can I track that interface so that if that interface goes down, HSRP will fail over? So let's get on to router 1 and let's take a look here. Let's say do show standby brief. What does router 1 think for group 10? What does it think its status is right now? We'll take a look. The status is active because router 1 thinks, hey, everything's great because I can communicate over here with router 3. So all is good, but all is not good because we've lost our uplink to router 2, the only way that we have to get out to that internet. So how would we fix this? Well, we would track this gig 00 interface on router 1. And if that interface, the line protocol on that interface is seen to go down, then we decrement the priority. Well, now we're going to come back to the preempt conversation. So over on router 3, how did we leave it? Remember, on router 3, with the use case we dealt with in the previous video, we saw that if these LAN-facing interfaces are impacted, HSRP knows right away, hey, I've lost communication with my peer, I'm taken over as and this is the standby saying, hey, the peer disappeared, the active router disappeared, I'm going to become the active. And we saw that that works, and that we don't show run interface gigabit Ethernet 03.10, we don't have a preempt statement, and that worked great. So let's see what happens when the HSRP messages are still being sent back and forth, but the preempt statement's not there. So let's see what happens. So first, we need to track that interface. Well, how do we do that? Well, we would simply come out and go to global config. And again, I say native into HSRP, but we have to configure this track statement out here because I'm going to track. And what's my tracked object? Well, I'm going to say the tracked object is 10. And then what am I tracking? Well, we're going to track interface gigabit Ethernet 00. And what about that interface am I tracking? I'm tracking the line protocol. Because if the line protocol goes down, in other words, the interface gets shut down or the cable gets cut in half, I want to be able to recognize that the line protocol has gone down. I'm tracking the line protocol for gig 00, and we've got a whole bunch of different options. We'll leave these out to the side right now, but let's get into gigabit Ethernet 03.10, our sub interface for the HSRP group 10. Let's see what's in here. Do show run int gig 03.10. And that's what we've got right now. And so here, where we have the priority set to 200, remember the default priority is what we left on group 10 on router 3, our standby. But I'm going to want to decrement this. So I would say standby 10, and what are we going to do? We're tracking object 10, and if we see something happen with object 10, an alert goes up saying that something with object 10 has happened, I'm going to decrement it by 101, because 200 minus 101 would take the priority on group 10 on this router down to 99. Which is less than the priority on router 3. And so now we're tracking the gig 00 interface so that if we lose this layer 3 connectivity and are uplinked to router 2, which gets us out to the internet, we're going to decrement the priority. How do we see that? Again, if I say do show standby, you'll see here that for 0310, the subinterface 03.10, right now our state is active. We've got our virtual IP, the virtual MAC. We've talked about that earlier. You can see the hello and the hold time in version 2 HSRP is 3 and 10. 3 seconds for the hello time, 10 seconds for the dead timer. And you can see the next one's going to be going out, the next hello packet here for HSRP. But most importantly, we see that we have configured the priority to be 200, and the priority is 99 if the interface is down. But what is my state right now? My state is active. So again, let's say do show IP interface brief. Gigabit Ethernet 00 is shut down. I just proved to you that the tracking works because look at that. The priority shows 99. So we're tracking the interface. The interface line protocol is down. We set HSRP up natively, or the built-in approach, to go ahead and decrement the priority if that interface goes down. That interface object we're tracking. Again, yeah, we're tracking an object. I'm saying it's built in, but I define the enhanced object tracking if you're using something like IPSLA. Here, it's sort of a more rudimentary vanilla tracking of the line protocol on the interface. So I've shown you that it's excuse me, that the interface is down, the priority has been decremented, but we come to PCA and no ping, right? It's not working. It never rolled over here. And I've been talking for more than 10 seconds. So again, HSRP thinks that it's still up here on these inside interfaces, even though the priority has gone down. So what is it that we're missing here? So again, it's all about the use case. Here, it's not that the communication with the HSRP neighbor has disappeared. It's that simply the priority has gone down. But router 3 is unwilling to do a coup, to run a coup on router 1 because we haven't configured what? We never configured the preempt statement. So here's where the preempt statement comes into play. Again, use case. How are things configured? What is it that you're trying to accomplish? How are we going to do this? Do I need the preempt statement with the previous use case and what we were showing? And the answer is no. But here we do, because router 3 is afraid to take over right now, even though that it sees in the hello packets that it has a superior priority. It's not set up to run a coup against router 1 in the event that the priorities shift. Let's take a look at show standby brief. And you can see for group 10, it still thinks, hey, I'm the standby, even though my priority is higher. I was never configured to take over. Let's make that happen. Interface Gigabit Ethernet 03.10. We're going to say standby. Don't forget that HSRP group number. And preempt, as soon as I put that in there, you're going to see some action take place. But most importantly, the action we're looking for is reachability from PCA has been restored out to that internet interface. Because now router 3 says, hey, I'm set up to preempt. And so for group 10, I'm going to transition from standby to active because what I've seen is that in the hello packets, I have a superior priority. So now do show, sorry about that, standby brief shows that I am now active for both of these. Now, router 1 already has the preempt statement configured. So what happens if I go into int Gigabit Ethernet 00 and say no shut? And we bring gig 00 back online. Remember, the entire premise here is that, sure, this path is great. If I lose my upstream reachability to the internet, I'll take this path and we'll take the hit to go the long route. But if router 1's interface gig 00 comes back online, hey, we want traffic to flow this way again. We want to take the shortcut to get out to that internet interface. And let me get rid of those last two arrows there. And so we want router 1 to preempt. Well, remember, router 1 was set up to preempt because that is what we would want to have. That is what we would want to have happen. So here on PCA, am I still pinging? Absolutely. That first hop reachability is there. HSRP as a first hop redundancy protocol has made that happen. Router 1 with the preempt statement has now had to run a coup against router 3 and taken back over the active role from router 3. So do show standby brief for HSRP group 10. I am the active. So why not do the same thing? So you're probably thinking, well, if I can do it for group 10, could we do it for group 20? Yeah, why not? Let's go ahead and monitor and track that interface, which uplinks router 3 to router 2. So we click on router 3. We're going to go ahead and go out to global config. I'm going to say, we're not going to track 10 here. We're going to track 30. I don't need to track 10 and I don't need to set it up on router 3 to track 10, because if that interface went down and it rolled over here and that interface goes down, well, then it's game over, right? So we don't need to track on the standby. We need to track on the router that's the active node. That in this use case, that's what we need to track. So I'm going to say track 30. And what is it we're tracking? Well, I'm tracking interface gigabit Ethernet 00, excuse me, and I'm tracking the line protocol. If that interface goes down, then I'd like to know about it because I'm going to decrement my priority by what? 101.03. Oh, I'm sorry. I said track 30. We wanted track 20. So let's get out of here and let's just say no track 30, because the group number is not 30. So let's say track 20, interface gigabit Ethernet 00, line protocol. Let's get into that subinterface, gigabit Ethernet 03.20, and we're going to say standby, come back here, standby 20, track 20, decrement. So standby for group 20, I'm tracking object 20, which is that gig 00 interface, and let me confirm that that is gig 00. And of course, I didn't check it, and it's not. It's gig 01. That's okay. Again, as I was typing this out, I'm thinking to myself, is it gig 00? So we're going to leave the standby track 20, and we're going to decrement 101, but we're going to get out of here. We're going to say no track 20, and I'm going to run this again. We're going to say track 20, interface gigabit Ethernet 01, line protocol. All right, so let's see what we've got here. Do show run int gigabit Ethernet 03.20. Do we still have our track statement there? We do. If I say do show track, it should show me what we're tracking here. And you can see line protocol is currently up, tracked by HSRP. And HSRP group 20, and that's what we're tracking on that sub interface, or it's set up on this sub interface, the HSRP sub interface, and we're tracking gigabit Ethernet 01. So we come over to PCB. Can PCB ping the internet? Take a look at that. It's been pinging it the whole time, no issues. Let's come up to router 3, and this is the kind of testing that you would want to do, gigabit Ethernet 03.20. This is the kind of testing you would want to do to make sure that we don't lose connectivity to the internet. And take a look at that. We caught it, it's shifted over, and now router 1, if I come over here and say do show standby brief, we should see that router 1 is now the active for group 20. And everything worked as it should. Again, the standby is unknown, and so let's come back over here to router 3, and let's bring that interface back up. And let's make sure that it swings back over here. And do show run int gigabit Ethernet 03.20. So everything is set up here, ready to go. Do show standby brief. We are now the active again for group 20. And what about PCB? Connectivity running without an issue. And so this is how we can track the interfaces. Now, you might be wondering, well, what if that interface, what if the use case is this interface here is up? So if I was to bring the eraser up and get rid of this here, what if this interface, we do have a triangle here with redundancy at layer 3. What about that? Well, we can do that as well because we can decrement multiple things that we're tracking. So we don't decrement, let's say that the first interface goes down, or if either of these interfaces go down, we decrement it by 51. And then if the second interface goes down, it would decrement it again by 51, which would be 102 total, meaning you've got it that it would then, the active role would fail over because the priority would have decremented. Router 3 is going to preempt. And so let's do that here just on the router 1 side and just for group number 10. And let's see what that would look like. So let's get into interface gigabit Ethernet 03.10. And let's say do show run int gigabit Ethernet 03.10. And let's say no, standby 10, track 10, decrement 101. So we're going to remove that. Let's make sure that it's removed because we don't want 101 to be, we don't want it to decrement by 101 if one of the interfaces goes down, because now both of those interfaces will be up. So we'll have another way to still get to the internet with layer 3 redundancy for our use case. So let's first get into int gigabit Ethernet. And let me confirm before I do anything crazy here. Router 1 and router 3, it's gig 02. So let's bring that interface back up. Gigabit Ethernet 02, we'll say no shut. So that interface is going to come up. OSPF is going to reconverge. There we go. We've gone from loading to full, or we will here in just a second. And you'll see that if I was to say do show IP OSPF neighbor, there's my adjacency. Now it's up here, right? So I've got 2 paths to reach router 2. One that's directly connected and one that runs over here as a backup on a layer 3 perspective over to router 3, which still allows me to get to router 2. So let's go ahead and say do show run include track. Whoops, sorry, and let's spell track correctly because we're not going to find anything with track D or track DK. So do show run include track. So we're tracking, and we've got group number 10 here, interface gig 00 line protocol. Well, that's great. So can I put another statement like that in here? Let's see what happens here, because when I say track, oops, sorry, let's get out of the interface subconfig mode. When I say track, it's the tracked object number, not the tracked group number. And you can see we can go from 1 to 1,000. So maybe to keep it so that I see that we're going in, sets of 10. So 10, 100, 1,000, or if it was for group 20, 20, 200, 2,000. Again, you could go start at 1, whatever the case may be. So we'll just say track 100. What is it we're tracking? We're tracking an interface. Oops, sorry. And that's going to be gigabit Ethernet interface 02. This is the interface on router 1 that goes over to router 3. And we're going to track the line protocol in case that interface goes down. Again, other options we could put in here we're not interested in right now. Let's get into interface gigabit Ethernet 03.10. And we say do show run int gig 03.10. This is what we've got configured here. So we're going to say standby group. The HSRP group number comes first. Standby 10, track 10. That's the interface to router 2. Or maybe what I could have done, maybe even better, track object 2 for router 2, track 3 for router 3. Maybe that would have been better. We'll leave it the way it is, but things to think about. So we're going to track object 10, and what's going to happen? We're going to decrement by 51 if that interface goes down, because it's going to take the priority down from 200 down to 149. And all I have to do is hit the up arrow here, and we're tracking 100 as well, and we're going to decrement it by another 51. So in other words, if one of the 2 interfaces goes down, the priority shifts to 149, but it still remains the active HSRP speaker in HSRP group 10. But what if we lose both interfaces? Then router 1 is dead in the water because it can't get from a layer 3 perspective up to router 2 to get out to the internet. So we would decrement the second failure by another 51 points, taking it down to 98. Yeah, taking it down to 98. Had to think that one through for a second. We're going to take it down to 98, which would be lower than the default priority currently configured on router 3, which is 100. So we've got these two statements in here. Let's take a look at the interface. And as you can see, we could track multiple interfaces. If I had a third interface that went out to router 4 and router 4 was connected to router 2, we could track that as well, but we'd have to watch those decrement values to make sure that we wait until all available interfaces from a layer 3 perspective upstream to the internet, right, had gone away. So we've got this configured now. Let's go ahead and pop out here. We're going to say write mem. Remember, we're already preempting over on router 3, watching that priority. So now what needs to happen is we need to test taking down one interface and then taking down the other. So the ping is running. I've got full reachability out to the internet. Let's come up here to router 1. Let's get into global config and let's first take down the interface between router 1 and router 2, which is gig 00. This is so convenient right here, which is gig 00. And we're going to say shut. Let's come to PCA. Let's see what's happening over here. Hit enter a few times and take a look at that. Everything is still working just fine. We had a little reconvergence up here, right? Because again, it's not HSRP that's handling any kind of failover right now. It's OSPF. So OSPF recognized that interface went down, reconverged, and now my shortest path to get to the internet is to come from PCA to switch 1 to router 1 over to router 3, up to router 2 and to the internet. Because again, this link, and let's go ahead and show what just happened here, this link right here is now down. It's gone. But we planned for that. We architected for that, for this use case. And the connectivity is here. But now, let's see what HSRP thinks is happening right now. So do show standby brief. Yeah, my priority is 149 because that interface that I was tracking went down. So I decremented by 51, but I'm still better than going from, still better than router 3. So I don't want the traffic to come all the way over here to switch 2 and then up to router 3. I want it to still come up to router 1 and then use that transit link to get to router 3. And so you can see here, the priority dropped to 149, but I am still the active because my priority is higher than router 3. But that's about to change because if I go into Internet Gigabit Ethernet 02, the link between router 1 and router 3, which I'm currently using, the only link that's up now for router 1 to possibly get to router 2 is through router 3. So what happens when I shut that down? We say do show standby brief. Take a look at the priority value. Now we've transitioned to the speak state here because we realize that something's up. And I've gone from speak to standby, right? Because I'm not the active anymore, my priority is 98. It is now lower than router 3. So let's check and see. Am I pinging? Are things still working great? It's working beautifully. But where did the redundancy and the failover take place? Was it at layer 3 with OSPF here when this link went away? No. We were tracking those two upstream interfaces and we noticed that they both went down. So that's when HSRP kicks in, takes over, and says, hey, the two interfaces that I was tracking and the values that I've decremented the priority by when those interfaces have gone down is now lower, meaning code red, double dog red alert, it's time for router 3 to take over. Do show standby brief. Now router 3, I think I maybe said router 2 a second ago there. Router 3 is now the active router. It owns the virtual MAC address and the virtual IP address for HSRP group 10, which if we jumped onto the switch and did a show MAC address table, you will see for VLAN 10, that Charlie 9 Fox, there it is. We own it. And I should say router 3 is we. Router 3 owns it. It's advertising it on this link. We see that layer 2 information. And so now PCA knows its default gateway is still to go to switch 1, but now it's going to come over here and up to router 3. And so there's another use case where if we did have layer 3 redundancy, how can HSRP still step in there and protect me against a failure? Again, it's all about the use case, right? It's all about the use case that we're dealing with. All right. Well, that is going to do it for this supplemental video tutorial on HSRP. And again, I'm saying built-in interface tracking because we're not using enhanced object tracking, which I kind of define as an IPSLA configuration. And we'll talk about that as well during the course. All right. Well, that does it for this video. Thank you so much for watching. Enjoy the rest of your weekend, and I hope to see you in the next video.